In this video, we will be going over the binomial theorem. So we're kind of going to separate from everything that we've kind of just been doing. And these next two topics, the binomial theorem and mathematical induction, are kind of more of a theoretical type of thing, and also a really cool trick to expand polynomials. So we've usually been looking at things like x plus y, and then we've been taking the cube of them, and now we just want to raise them to some power n. So the whole point of this is that we want to be able to come with a couple of tricks that will help us figure out these expansions that can take a very long time. So the first thing that we're going to talk about is factorials. So factorial, basically what that is you denote it with n and an exclamation point. So this exclamation point in English means something completely different. So the way that we say this is n factorial. And basically what n factorial means is that you start with the letter n, and then you multiply by subtracting one consecutive, one from each n. So then there will be n minus 2, n minus 3, and I continue doing this until I get to 3 times 2 times 1. So for example, if you want to see a concrete example, we use 4 factorial. What that means is that you're going to do 4 times 3 times 2 times 1. And then you do it and you just get 24. So basically 4 factorial means that you start with 4 and subtract 1 from each time. So you can do this for any different number that you want. Now you have to be very careful because factorials can they can kind of be a little bit they go to infinity really quickly. So a really quick and easy way to do factorials instead of just multiplying everything out, in your calculator, if you have the TI-36, you're going to see this button, n factorial, and then you're going to see NCR and NPR. Press that button. So press the number. If you want to write 4, press that number and you'll be able to get the factorial sign. So those are what factorials are. So 0 factorial by convention is just equal to 1. Now the reasoning of why we have factorials, and you might be wondering why would we want to multiply it, it does come up a lot in statistics. It comes out a lot in combinations and permutations, different ways to kind of just choose different items. So for example, let me give you this quick example of a combination. So how many ways can I choose 2 chips from 4? Okay, so basically let's say I can only choose 2 chips, and these are 4 different chips. Well, how many different ways can I get them? Well, the answer in this case is 6 different ways, because I can choose these 2 if I wanted to. I can choose these 2. I can choose these 2. I could have chosen the first and the last one. I'm sorry, the first and the third one, the second and the last one, and then I could have chosen the first and the last one. So how many did I do? 1, 2, 3, 4, 5, 6. That's 6 ways that I can do that. Okay. Now, if I have many different items, it'll be really difficult to do. So instead, what we do have is a formula that will tell us how many different ways you have to choose x number of items from n total items. And the way that we do that is something called the binomial coefficient. Okay, and basically the binomial coefficient, what it does, you see this n and then r. So this just is just fancy notation for from n items we're choosing r. So n choose r. So we're choosing r items from n. So in this case, the way that we figure this out is there's a formula that says n factorial over r factorial times n minus r factorial. Okay, so there's the formula that we have. So this will tell us how many different ways you have to choose r items from n total. So in this case, we are looking for n. In this case is going to be the number of items that we choose. So we're from, I'm sorry, n is going to be the total number of items. So in this case, I have 4 total chips. So from 4, I am choosing 2. So that the way that you say it is 4 choose 2. So we're going to plug them in. 4 factorial. R in this case is going to be 2 factorial. And then 4 minus 2 factorial. So you're going to get 4 factorial over 2 factorial. That's just going to give me 2. And then that's going to be 2 factorial, which is also going to give me 2. Okay, so it's going to be 2 times 2 on the bottom. So now what we're going to get is 4 factorial over 4. 4 factorial is just 4 times 3 times 2 times 1. And we have a 4. Notice that the 4's cancel out, and I'm left with 6. So you have 6 total ways to get from 4, you're choosing 2 different chips. So you have 6 total ways. In your calculator, you can also do something like this. And let me show you real quick. My calculator, so what you want to be able to do is locate for the NCR button. So the NCR button is going to be right there where the factorial sign is. So if you wanted to find 4 choose 2, okay, then the way that you're going to do it, you're going to start out by putting the number 4, okay, and then we're going to press NCR, but notice that the first time that we press it, you're going to get factorial, so you're going to press it twice. So factorial, we don't want that, we want NCR. And from there, we're going to press 2. So 4 choose 2, and you'll see that you get 6 different ways. So it's a really quick and easy way to do it. So if you have a different type of calculator, you might have to do a little bit more. You want to look for PRB, but mainly this calculator is really powerful. It'll help you do it instead of doing the entire factorial stuff. But I did want to show you how to do it the long way. So if I wanted to say from 7 items, so let's say I had 7 of them, and I wanted to choose 2 of them. So if I had 7 chips and I wanted to choose 2, then that will tell me that there's 21 different ways in which I can do that. So that's kind of how you use the NCR button on the calculator. And you can do many different problems using this NCR button. So remember that this N choose R, basically you can do it by pressing NCR in your calculator. So you don't have to do all of this work, okay? Now here's the question, like, why do we want to know this? So the first thing that we kind of want to do is that we want to start off by trying to expand polynomials. So for example, we have x plus y to the power of 0. Well, this is easy. This is just going to give me 1. Okay, and then let's say I want to expand x plus y to the power of 1. Well, that's to the power of 1 is just going to be just regular x plus y. If I were to FOIL out x plus y squared, so I'm going to FOIL everything out, you're going to get x squared plus 2xy plus y squared. What about if I wanted to do x plus y to the power of 3? Well, that's going to give me x cubed plus 3x squared y plus 3xy squared plus y squared. Okay? Oh, that should be y cubed. And then what about if I wanted to do x plus y to the 4th power? Well, that's going to give me x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. So this is just me doing it. I'm not just knowing what that is. I'm just basically telling you what it is when you FOIL everything out. And you can keep doing it. So the whole purpose of this is that I want to come up with some sort of pattern that I see. Since we're since we just finished sequences and series, we want to be able to come up with a pattern. And the pattern here is, well, let's think about what's going on. Well, you see in the beginning there really is no pattern, but you can see that in the x direction. So you see that our x's tend to increase by 1 the more that we continue. Okay? The higher the power, the x's tend to go up. Same thing with the y's. They also tend to go up. Now, what is happening in the middle? So in the middle, there's no middle term. But notice here that you have an x and a y. Okay? Notice that if there were a power of 1, 1 plus 1 will give me 2. Okay? So that's going to give me a degree 2, just like the rest of them. If I look here, 2 and 1, and then 1 and 2, you can see that these guys are also degree 3 combined. Now, what else do you notice? You see the same thing with this one too. You see that the powers here are a power of 4. Now, what else do you notice is the following. So you can see that for the first x, you have two x's, x squared. Then you have 1x, and then you have no x. Here you have x cubed, then x squared, then 1x, and then no x. Then you have x to the fourth, x to the third, x squared, 1x, no x. For the y's, you can see that I have, from the opposite side, y squared, 1y, no y. Y cubed, y squared, y, no y. Y to the fourth, y cubed, y squared, y, no y. So you kind of see a little bit of a pattern. So basically, let's go ahead and write this down. Let's try to figure out what this should be. So if you want to expand x plus y to the power of n, so notice that our x's, they start off with whatever the nth power is, and then you keep subtracting by 1. Okay, n minus 1, then x, n minus 2. And then you continue on until you have no x. Okay, so there's no x there. For the y's, what you end up doing is that you start off with y to the n on the outside, then you subtract by 1 continuously. So here it will be y squared, then a y, and then no y. Okay? Alright, so that's basically what the x's are doing. X's are going downward by 1. My y's are going up in the opposite direction. Now, what about my coefficients? Well, my coefficients actually, notice that these are all 1. This guy is just n choose 0. Okay, so if you plug in any n value, and then plug in NCR, put in 3 NCR 0, and see what you get. You're going to get a 1. Okay, the other one is going to be plus n choose 1. Then the other one is going to be n choose 2. And it's going to continue on until you get to n choose n. So this thing, what I just found is a really crazy formula, which is what we call the binomial theorem. Okay? And basically what this says is that if I wanted to expand something to the power of n, all I got to do is use this binomial theorem formula, and that will give me the expansion. Try to do a problem. So let's try to do maybe x plus y. That's a lot. Let's do x plus y cubed, and let me show you that this actually equals that. So let's try to use the binomial theorem. So use the binomial theorem to expand x plus y to the power of 3. Okay, so what we're going to do is the following thing. So we're going to start off with x plus y to the power of 3. And then we're going to start off with the first term, which is going to be this n choose 0. So n in this case is going to be this 3. So that's going to be the power. So it's going to be 3 choose 0. Okay. Then you're going to have x to the power of 3. That's the first thing. Then you're going to go to the next one. Plus 3 choose 1. Then you're going to have x. Then you're going to plug in the 3. 3 minus 1. So now they're at 2. And then you're going to have now a y in there. You're going to have a y. Then plus. Now let's go to the next one. So now it's going to be 3 choose 2. Now x, that 3, now we're going to subtract it. Now we're going to subtract 2. And what's going to happen to the y? The y now is going to increase from a 1 to a 2. Now we're going to add. So now it's going to be 3 choose 3. So now the x, which had a power of 3, now we're going to subtract 3. And the y, we're going to continue adding 1 till we get from a 2 to a 3. And that's where we stop. So when these numbers are the same, that's where we stop. And now all you got to do is just use your calculator. So just use NCR. So you're going to go into your calculator, put 3 NCR 0, and you're going to get a 1. That's going to be x cubed. That's this guy. Then you're going to press 3 NCR 1. That's going to give me a 3. It's going to give me x squared and then a y. Then you're going to get 3, choose 2. That's going to give you a 3. And then this guy is going to be just x to the first and then y squared. And then the last one is 3, choose 3. That's going to give me a 1. X to the 0 power is just a 1, and then you have y cubed. So basically the entire solution is going to be x cubed plus 3x squared y plus 3xy squared plus y cubed. And as you can see, this guy is exactly as this guy, okay, which is like magic, okay? So someone figured out, you know, that these guys, the coefficients are just the binomial coefficients, okay, which is pretty cool. All right, so now let's do one that's a little bit more complicated. So let's say you wanted to expand, and notice that the more terms that there are, the more complicated this is going to get. So I would think that I would only ask you up to a power of 4 or 5 maximum. So let's try to do maybe 2x minus let's do 3y. So let's say you wanted to do this, and let's say you wanted to do it to the power of 3. So we want to use the binomial theorem. Okay. So what we're going to do this, you have to be very careful now, because let me do it in a different color. So we're going to write 2x minus 3y to the third. So basically notice that now we don't have just an x, we have a 2x. Okay. So let's start off with the binomial coefficients. Okay. So the first one's going to be 3, choose 0. Then you're going to have 3, choose 1. 3, choose 2. Whoops. 3, choose 2. And then 3, choose 3. Okay. So that's what we're going to have in the beginning. There's going to be pluses all in here. Okay. Then my x's, notice that my x's are basically increasing. I'm sorry, they're decreasing. So they're starting at n and we're subtracting 1. Now, be careful because there's no x's here. We have a 2x. So what we're going to do, we're going to put that in parentheses, 2x. We're going to start that 2x at a 3. And then we're going to continuously subtract 1. So now this guy's going to be 2x to the second, then 2x to the first, and then 2x to the 0, that's going to be gone. My y's are going to be increasing. Notice here, they're decreasing in the opposite direction, so they're increasing one way. So we're going to take this negative, so we're going to include this negative in there too, because notice how there's positives. We're going to choose that negative there. So here, this guy is going to get a negative 3y cubed. Then you're going to write negative 3y squared, negative 3y, whoops, negative 3y to the first power, and then no negative 3y there. Okay. So then we're just going to do this. So this guy right here, 2 to the third power, that gives me 8. So that's going to give me 8x to the cubed plus 3 choose 1, that's going to give me a 3. This guy, 2 squared, that gives me a 2. I'm sorry, that gives me a 4x squared. And then times, this is going to stay the same, negative 3y. Plus 3 choose 2 is going to give me 3. This is going to give me 2x. And then negative 3y squared, that's going to give me a 9y squared. And then finally, 3 choose 3 gives me a 1. Negative 3 to the third power, that's going to give me negative 27y to the third. Okay, so cleaning this whole thing up, you're going to get 8x cubed. So now let's multiply these guys out. So you're going to have 3 times negative 3 gives me negative 9. Multiply it by 4, you're going to get a negative 36. You're going to get x squared y. Then you're going to have a 3 times 2 times 9. That's going to give me a positive 54 x y squared. And then negative 27y cubed. Okay, so this is going to be the full expansion. Okay. Now, this is a little bit complicated and it gets a little bit out of hand. There is an alternative way to get the coefficients. Since you have NCR, this is a way that you can do it. Another way that you can do it is something called Pascal's triangle. Okay. And what I'm going to show you Pascal's triangle in the next video.